Okay, so just for some practice, we're going to have you write down what this is in terms of only one variable. In other words, you can't use x and y for the sides. So what do you think? X and 3x? Raise your hand if you said something like that. Good. All right, here's a little bit more difficult. The area of the rectangle is 70. Now tell me the length of the sides. I know you don't know for sure. Could be 7 and 10, but you don't know that. So what do you put? Well, one side you can just pick and say, I'm going to call this x or n or whatever. But then the other one you have to figure it out and use a 70. And how are you going to do that? Well, how about this? Can you tell me a little equation you could write to figure this out? What's area normally? Length times width. And what is the area in this case? 70 equals the length times the width. And which one do we want here? Do we want the length or the width? We want the length. And what are we calling the width? X. And so you could say that the length, if I wanted to know what this length is here, it's going to be solve for L there. And it would be 70 over X. Raise your hand if you had that one right. All right, that's less of you, but now I hope you can see that that would work. Think of it this way. If you took this times this, wouldn't you get 70? It's kind of the point, that x times 70 over x, the x's would cancel and you'd get 70. All right, let's do another one like that. Let's say that I had a box and its perimeter was 28. Tell me its sides. You'll have to use a variable, but only use one. No. Just a whole new problem. The perimeter is 28. That's all you know. You should be able to tell me the lengths of the sides in terms of one variable. I'm starting to review for the final too here, because final obviously is coming. We are only going to have like 3 or 4 days to review for 8 tests you've taken. The final will have a bunch of R3s, just like each test had 4 R3s on it. This and 4 R2s. This giant final will have like 40 R2s and 40 R3s on it. So you'll have like 80 questions, and it'll be graded the same way with Marzano, meaning you should really focus on your R3s, and if you can get, how many right do you need to get on a normal test? 3 out of 4, right? So what are you going to need to get on this? Like 30 out of 40 of your R3s right, and you'll get an A. It's the same grading style. Okay? It usually helps kids. Most kids do better on this final than they would if it was a normal math final. Yes? Nope. Well, wait. It's the vast majority is multiple choice, but there are problems that are not multiple choice on it. Okay. So yeah, they're just normal problems. They're just harder, and like there are 3-level problems there, so they're more challenging. Then there is a couple R4s on it, so you have a chance to get 100%. And the R4s are not multiple choice. Okay. So the perimeter is 28. Well, if I pick this side to be x, then think about this. If the total is going to add up to 28, then this also is going to be an x over there, right? And then this thing and this thing together, whatever they are, have to add in with it and make 28. Would you agree there's probably some kind of an x in it? And like I do something with the x, like, 15 minus x or something like that, or whatever it is? Well, what if I added up x plus something plus something, and I needed to equal 28? minus x. If I did 28 minus x and 28 minus x, that's getting the right idea, because the minus x's would have canceled out, but then I'd have 48. So you're getting close. 28 minus 2x is If they were both, are you saying both of these sides should be 28 minus 2x? That's not going to work because 14 minus what? So if it was 14 minus x and 14 minus x, would that actually add up to 28? Because the x and the x would add up to 2x, and then these would take it away. And now I got 14 plus 14 makes 28, and it works. So 14 minus x. Yay. So x and 14 minus x are the two sides. Could I have done that with a formula? Sure. Here's how I'd do that. So using the formula, I'd say perimeter is 2 lengths plus 2 widths. And what am I calling my widths? They're called x's. Perimeter is 2 lengths plus 2 x's. And do I know the perimeter? Yeah, it's 28, so I can put a 28 here. And then I just have to solve for L. Oh wait, and W is now an x. Wait a minute. This is supposed to be 2L here. And there we go. Okay, so now I can solve for L. So I would subtract from both sides. 28 minus 2x equals 2L. And then I divide both sides by 2. And L equals, divide those both by 2, 14 minus x. And again, the proof is in the pudding. If I can add this plus this plus this plus this, and they all add up to 28, then I must have did it right. One more like that. Perimeter equals 100. Figure out how long sides are. Some of you guys are pretty logical and would say, well, this is just like the other one, so therefore it would be what? 50 minus x. How would you be sure you were right? See if they all add up to 100. So I go, if I add this, all the sides together, you get how that'll be 2x, and this will take away the 2x's, and then the 50 and the 50 will make 100, so it works. Yay. So x and 50 minus x are the two sides. All right, why would you do that? Because it'd be in the middle of a problem that was much more complicated, of like maximizing the area or whatever. But just wanted you to think along those lines because we're getting you ready for the future. Okay, if you see this problem, you will not multiply by x plus 9 because that wouldn't fix the whole thing. You would multiply by x plus 9 and x minus 1. Take a minute, multiply it all out. This will take like half a piece of paper. But if you can't handle it now, you're not going to be able to handle it on the test. So you need to practice it. All right, from here, you just have to get all the x's onto one side. If you could put that device up on my desk, I'd appreciate that. Thank you. It's not the time for that. You get it all onto one side, and then you would say equals 0, and then you got this big old 7x squared, blah, 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 and then how are you going to solve it? 3 ways. Factor it. If it doesn't factor, what else? Graph it. What if it doesn't graph? Well, if it would probably graph if it would. If it didn't graph or factor, there's one last way. Quadratic formula. Yep. Quadratic formula would solve any quadratic. So let me just finish this up. It would be, put that over there, it'd be minus 61x, and put that over there, it'd be minus 108. That's pretty ugly. Probably you need a calculator to graph that puppy, or even use a quadratic formula on it. Yes? Oh, okay. The little green stuff here, that multiplied out to make that. There you go. It was multiplied on all three parts. All right, so that's the nitty-gritty. Like, that's probably one of the hardest kinds that you have to know how to do. All right, so I keep on coming back to it. Hopefully you're still remembering it. Do you know this formula? If you do, it should be easy. 76% acid, it doesn't say how much, is added to 5 milliliters of 80% acid until it brings it down to 79% acid. How much acid must you add? So that's how much of the 76% of the acid must you add. So in other words, how much of this stuff must you add? So I like that formula. Amount 1, percent 1. Amount 2, percent 2. A1 plus A2 total percent. Okay, multiply it all out, find it. Find N. Figure out how much of that stuff do we need. It'll take you a minute, but again, if you can't do it now, you won't be able to do it later. Yes? Yep. Just leave, actually don't have to leave anything, just grab calculator. Somebody help me out with 0.79 times 5. Can't do that in my head. Thank you. Just grinding it out. There's nothing really complicated here. It's just knowing how to solve equations and using your calculator a little bit. Final answer, what is 0.05 divided by 0.03? 1 point what? 6 something? Raise your hand if you had it. Well, about 1.6. All right, good. All right, now we go back and think in the context of the problem. We only need to dilute our acid from 79% down to, or sorry, from 80% down to 79%. So we don't need to dilute it very much. So it shouldn't take very much acid of this stuff to do that. So we should just add a little bit. So that makes some sense to only add a milliliter of acid. Don't need a lot. All right, moving on. This kind. By now, hopefully these are like second nature. Just don't even do it. Tell me what to do. Somebody in the back row, tell me, how do I start? Put the zeros on the graph, okay? 5 for this one. What's that one? -2, and then what's that one? +1. I'm going to swap this around, put a 1 here and a 5 here. Okay. Second, or let's go front row. Somebody in the front row, tell me what to do now. I've got these 3 spots. Give me something to do. Test other ones, okay? So test, tell me some numbers in between. 0 would go in here. How about in here?
2.
How about 2? That's a nicer number. How about over here? Okay, how about over here? All right, good. Now, get different people. How about people in the second row? Tell me, second rowers. if I stick in -3 into this, all I care is not what the answer is, is it positive or negative? Is the first one come out positive or negative? Negative. Then, does the second one come out positive or negative? I think that's negative. And then the third one, this one right here, does that come out positive or negative? Oh, wait a minute. He was right. It is positive. It's positive why, though? Because it's squared. That's right. So it was negative in there, but then it got squared, so you're right. It's positive. Sorry about that. And then the third thing I check is this one right here. When I put in a -3, what is it? So then it's 2 negatives in there, which makes the answer. 2 negatives make a positive. Okay? Did I do something wrong there? I'm getting some quizzical looks. I might have. Do you get how I got 3 parts? This part was right here. That part was negative. This part is right here. That part would have been negative, but it got squared, which makes it positive. And this part right here is negative, and that's this part right here, and that's just -3 minus 1 makes -4. So yeah, it's negative. So then there's 2 negatives in this little group of 3 things, and that makes it positive. Okay, so you test every spot. How about these spots? Do you test them? Yes, you do. You test them too. You find out if they work or not. Mr. J, if I stick in -2, it's going to make this middle part 0. What does that mean? What if this part becomes 0? What happens? And if the whole thing becomes 0, does it work or not? Does not work because it says greater than 0. 0 is not greater than 0, so you leave it empty. On the other spots are also zeros, so they also won't work. So these are all empty circles. Okay, and then I got to test all these spots. Let's say it came out like this. Then you're looking for the ones that are greater than 0, which would be this spot and this spot, the ones that are greater than 0. Okay? All right, moving on. This kind. These are a little different just because you've got to not only put the x-intercepts on, you got to put the asymptotes on this line. Would you please figure them out, put them on the line, test the intervals, do this whole one from start to finish. This is the new stuff for today. It's supposed to be the vertical asymptote stuff. We've already done it a couple days now because I've been working you up to it. And I'm feeling kind of sad because this is one of the last things that I'll teach you till the end of January, and then some of you will be gone. I looked at my class list, like half of you guys are going to be gone. It's like a bigger, like I lose more kids than ever. All right, so you should have said 1 was on your list, and so was -6 and +5. Wait a minute, I should probably let it like this. -6 and 1 and +5. Those are the 3 things. One of them's, or a couple of them are asymptotes. The 2 that are asymptotes are this, and those are empty spots right off the bat because asymptotes don't ever work in your function. They can't be less than 0 or greater than 0 because they don't exist. And then this one, I should test it and see if it's an empty circle or a filled in circle. If I put in a 1, it'll give me 0. 0 is not less than 0. That's an empty spot too. Now you got to test all your intervals in between. Mr. H, would you tell me what happens if I put a 4 in? Maybe I said I'm not going to say a name on the screen, so I'm just going to point at this guy in the back right there. Go ahead. Mr. Minnesota Hockey. Okay, so this 4 here, if I put it in, what's going to happen? What's that? Yep, so it's a positive number. All you really need to know is it positive or negative? That's positive on top. And then on the bottom you would get, come on, what's that? So it's positive or negative. It's positive. And what's that? So, if I have a positive and another positive and then a negative, what's that going to come out to be? Yep. Because there's 3 negatives in it. That will be negative. I am worried for you officially now. Maybe it's because of the pressure of me calling on you, but that was an easy question. You should be able to handle this. If not, then your pencil should be moving more instead of just sitting there pondering. All right, moving on. Look at this one. If I put in a 6 right here, so take notes. In the back corner, hit me with this one. If I put in a 6, what do I get there? Positive or negative? And there, and there, and so the answer is, there you go. You had a tough one. All right, let's go up here. Front right. Tell me a number you tested here or here.
I did 0.
Okay, let's between negative 6 and 1. And that's where 0 would be. Okay, so let's test 0. If I put in a 0 here, what do I get?
Oh, at the top?
0 minus 1 is negative. Okay, over, what do I get down there? Positive and a negative. Good. So now it's got 2 negatives and 1 positive. Final answer is positive. All right. And now let's go with the person who looks bored now that they're not texting. Go ahead. Tell me a number that's on this side of the negative 6. Okay. And then negative 7, negative 7, negative 7. You are right. It's negative on the top. And then negative and negative. Wow. So the final answer is correct. Okay. So now I want the ones where they're less than 0. That's this part and this part. Final answer. Write it on your paper. See if nothing else, if you haven't been keeping up with it until now, you should be able to interpret and say where did it work. From here to there, comma, or union there to there. All right, it worked from here to here is negative infinity to negative 6. And this, it didn't work at negative 6, so it's parentheses. Union with, in that zone, it's 1 to 5, parentheses on both of them. Raise your hand if you had that at the end of your paper. Okay, good. So, this one. It's a combo of 2 kinds of questions. You know, generally you want to get rid of fractions, right? So what do I start by doing? Multiplying everything by what? Multiplying by everything by x plus 7. I don't need to worry about this x here because it's over 1 and everything's over 1. So I just multiply everything by x plus 7. Go ahead and do that and then leave the greater than sign in there and then rearrange it so it's got a 0 at the end. Make sure it's got a 0 at the end. Well, that really won't be a problem because 0 times x plus 7 will equal 0 anyways. 2 plus x squared plus 7x is greater than, and all of this becomes 0 anyway. Testing this is on Wednesday. All right, so x squared plus 7x plus 2 is greater than 0. Now, if that would just factor, it'd make my life a lot easier, but it doesn't. So, how can I find the zeros, though, if I can't factor it? Could graph it, all right? Once I graphed it, I figured out what the zeros were. Let's say that they were like 2 and 6. Then I just do it like normal. Find where it works and where it doesn't. Check numbers here, here, and here. Check the spot 2 and 6 to see if they work. And okay, so this problem, just because it starts off with a little something weird, it still ends the same way with the sign chart and piece of cake from there. All right, this one. Hardest one of them all. If you can handle this, we're done. What I'm mainly concerned with is, can you find everything on the number line? From there, I know you can test intervals. At least I think you can test intervals. So remember, we do all of the x-intercepts, which are the things on the top. 8 and 2. And we do all of the things from the bottom, which are the whats? The verticals. The vertical, one of them's 8. No, 9, sorry. One of them's 9. And asymptotes never work. Empty spot. And the other one, how can I make this right here equal 0? Well, I'm going to try it off to the side. 6x squared plus 1 has to equal 0. So that means 6x squared has to equal negative 1. And that means x squared has to equal negative 1/6. And that can't work unless I use imaginary numbers. Do you have to use imaginary numbers in a number line? No, you wouldn't know where they were on a number line. So therefore, I can just throw that part out. Don't have to worry about finding an asymptote for that thing. All right, so now I'm down to, let's just see if these spots on the line work or not. If I put in a 2, would it work? Well, it would become 0 right here. And if the top is 0, the whole rest doesn't even matter. 0, the whole thing would become 0. Is 0 less than or equal to 0? Yes, so it works. And the other thing that was a 0 also would work. There we go. And now all I'd have to do is test the rest of the intervals, and from there it'll be easy. Okay? All right. Now there's one old reading number chart thing, which should be it. Nothing new here. See if you can write the answer. If this is how the number chart looked, what would the answer be? It's a different way to ask the question. And it's actually a very easy one. It should be an R2 level question. All right, so you're thinking, where is it less than or equal to 0? In that whole range right there. So it's negative infinity to 1. Is there anything else, though? Yes, union with. It also works there. Just there, so it's just the 5. That's a weird looking answer, but it's right. There is no 6. Oh, I see what you mean. I'm sorry. At the negative 6. Okay. No, because it works all the way through there. It worked all the way from negative infinity up until negative, or up until 1. So we don't have to even note the 6. Yes. Wait. No, if the 5 had a hole, it would not be working, and therefore I would not include it in the answer. Okay. Any other questions? Did you have a question, sir? I would have accepted it, yes. If you would have said negative infinity to negative 6 with a bracket on the 6, and then a bracket again, negative 6 to 1 with a parenthesis on the end there. Yep, that'd have been okay. It's not as clean, but it's right. Okay, good. I think you've learned everything you need to know up to this point. So, we'll give you your homework. It's out of the book.